Paul Ernst was a gifted physicist and a close friend of Einstein, who even described him as the best teacher in our profession. Despite his scientific success, Ernst lived a life marked by doubt and depression. Born in 1880 in Vienna to a poor Jewish family, he was the youngest of 5 children. He lost his mother at the age of 10 and his father at 16, making his childhood difficult and unhappy. Despite all this, he found happiness in his deep love of mathematics and physics. In particular, he attended Ludwig Boltzmann's physics lectures. Ernst began studying chemistry at the Vienna University of Technology, but moved to Göttingen, Germany, seeking a richer scientific environment where he immersed himself in mathematics and physics. In Göttingen, he met Tatiana Afanasieva, a Russian mathematics student. He wondered why she wasn't attending the mathematics club meetings and discovered that women weren't allowed. He campaigned and succeeded in changing the rules. When Tatiana joined Paul in Vienna, he was completing his doctorate under Boltzmann's supervision. They wanted to marry, but Paul was Jewish, and Tatiana was a Russian Orthodox Christian. An Austro-Hungarian law prohibited interfaith marriage. So they renounced their faiths and married in 1904. 2 years later, Boltzmann committed suicide. He suffered from depression, asthma, and a severe fear of lecturing. Ernst was devastated. To secure his legacy, he dedicated himself to simplifying and conceptualizing Boltzmann's abstract ideas in statistical mechanics, collaborating with his wife on what became Ernst's famous diffusion model. Imagine 2 containers, each holding 100 balls. At each step, you randomly select a ball and transfer it to the other container. The balls move back and forth, and over time they tend to cluster around an equal section, about 50 balls in each box. You will occasionally see fluctuations such as 60-40 or 70-30, but the system always returns to equilibrium. It is a simple and effective way to illustrate how random motion drives systems toward equilibrium, the same principle underlying the mixing of gases or the diffusion of heat in a room. Ernst developed his model while living in St. Petersburg, then the capital of the Russian Empire, fulfilling a promise he had made to his wife to settle in her country. Ernst immersed himself in scientific research. Another example of his working grounding is his paradox. Imagine a disk spinning at nearly the speed of light. Every part of its edge moves along its length, so special relativity predicts that its circumference will contract. But the radius points outward, perpendicular to the motion, and remains unchanged. The result is a paradox. The circle no longer follows the familiar rule that its circumference equals 2p times the radius. If the disk were made of a real material, it would not remain perfectly solid, because internal stresses would cause it to deform or even break apart. The paradox indicates that the geometry itself changes, and that space in a rotating system is not flat but curved. This was direct proof of the accuracy of Einstein's theory of general relativity. Yet, despite his talents, Ehrenfest could not find stable employment. He was a foreign Jew, officially registered as without religion. By then he had 2 daughters with Tatiana and dreamed of settling permanently in Russia. But insecurity weighed heavily on him. His fortunes changed when he travelled across Europe on a lecture tour of German-speaking universities in 1912. In Berlin he visited Max Planck. In Leipzig he met his old friend Gustav Herglotz, and in Munich he met Arnold Sommerfeld. His journey then took him to Zurich, Vienna, and finally Prague, where he met Einstein for the first time. They hit it off immediately. Within a few hours, Einstein recalled, we were true friends, as if our dreams and ambitions had been made for each other. Beyond their personal relationship, Einstein admired Ehrenfest's intellect. This respect gave him a boost of confidence at a time when he felt neglected. Einstein even suggested Ehrenfest as his successor in Prague, but he declined. The position required formal religious affiliation, something he had abandoned. However, this was of little consequence, as another opportunity was on the horizon. In April 1912, Hendrik Lorentz began searching for a replacement to head the Department of Theoretical Physics at Leiden University in the Netherlands. Sommerfeld praised Ehrenfest, saying, "He lectures like a seasoned expert. He knows how to simplify the most difficult concepts and make them intuitive." 5 months later, in September, the news finally arrived by telegram. Ehrenfest has been appointed professor at Leiden. Warmest congratulations, Lawrence. Ehrenfest was overjoyed. He replied with deep gratitude, "I will do my utmost to live up to the expectations of the gentleman who deemed it appropriate to appoint me as your professor." The Ehrenfest lived a simple life in their newly built home in Leiden, preparing vegetarian meals and abstaining from alcohol and smoking. Despite the simplicity of their food, their conversations were rich and engaging. Their home became a meeting place for some of Europe's greatest scientific minds. Einstein visited them frequently when he was appointed a prestigious professor in Leiden. They would play music together, and Einstein would sometimes change Ehrenfest's mind from Beethoven to Bach. Einstein admired his unique talent for teaching, later saying, "He was not only the best teacher I have known in our profession, but he was also passionate about the development and destiny of mankind, especially his students." Besides being lauded as a teacher, Ehrenfest also produced works that had a lasting impact on physics. One of his most important ideas, published in 1914, addressed the issue of adiabatic constants. Imagine a pendulum swinging back and forth. If you shorten the string of a pendulum very slowly, it will still swing smoothly without deviating from its rhythm, but its frequency, how many times it swings, and energy, how high and how fast it swings, will adjust to maintain a constant energy-to-frequency ratio. This constant ratio is what Ernst called the adiabatic constant. This insight revealed properties of physical systems, whether in atoms, oscillators, or intracavity radiation, that remain constant when conditions evolve slowly. It became the foundation of early quantum theory. During the war years, Ernst's home in Leiden was the center of energy and ideas. Paul and Tatiana chose to homeschool their children, believing that schools stifled their curiosity and that learning should flourish freely at home. They grew up in a family of 4 children. The youngest, Wasik, was born with Down syndrome, a burden that weighed heavily on the family and later played a tragic role in Ernst's life. By the 1920s, Paul Ernst began to feel alienated. Physics was moving away from the concrete, visual thinking he loved towards something more abstract. He struggled to keep up with the rapid advancements of the younger generation, including Werner Heisenberg, Erwin Schrödinger, Wolfgang Pauli, and Paul Dirac, whose bold new ideas in quantum mechanics were transforming the field. Despite his feelings of inadequacy, Ernst published what many consider his most important scientific contribution. In 1927, he linked the strange world of quantum mechanics to the familiar laws of classical physics. Quantum particles, such as electrons, behave in strange, wave-like ways. They don't follow precise, fixed paths like planets orbiting the Sun. Instead, we can only predict the probabilities of finding them in different locations. Ehrenfest's theory showed that if we average these probabilities over time, these averages obey the same rules established by Isaac Newton centuries earlier. Although individual quantum particles behave unpredictably, their average motion still reflects Newton's laws, an achievement that connects the quantum world to the familiar laws of motion we observe every day. Nevertheless, his sense of inadequacy persisted, exacerbated by the pressures of the Great Depression. He was convinced he would be dismissed from Leiden University. During his period of depression, he began an affair with a young art critic named Nellie. Once his wife discovered his infidelity, she filed for divorce, further deepening his despair. Einstein became so concerned about his mental state that he wrote to the Leiden University Council requesting a reduction in his workload. But his friend was unable to help. The gloom that gripped Ehrenfest seemed to mirror the gloom that had spread across Europe. When the Nazis seized power in neighbouring Germany, anti-Semitism swept across the continent. His youngest son, Wasik, who had Down syndrome, was placed in an institution in Germany. But as his health deteriorated, his family moved him to an institute in Amsterdam. It was there that Ehrenfest carried out his final tragic act. He had been contemplating it for some time. In 1931, he wrote a letter to his friends Einstein, Bohr, and others. In recent years, it has become increasingly difficult for me to follow developments in physics with understanding. I have finally given up in despair. This has made me extremely bored with life. I am focusing more and more on minute details. Forgive me. He never sent the letter. It was found in his possession after his death. Today, Paul Ernst is often overlooked. He is largely forgotten, even among physicists. But his biographer, Martin Klein, captured his significance in this way. No man was more deeply involved in the struggle to formulate the concepts of 20th century physics, nor more committed to maintaining clarity and transparency in the face of new developments. His efforts were recognized by the informal title bestowed upon him by his colleagues, the conscience of physics. Despite the tragic end to his life, Paul Ernst left a profound legacy in the world of physics. At the Leiden Institute, he established a school of thought characterized by scientific rigor and a pursuit of deep understanding above all else. He consistently encouraged his students to ask fundamental questions, even those that seemed obvious to others, because he believed that true science begins with doubt. His influence extended beyond physics itself, reaching scientists directly. He was a mentor and close friend to leading physicists of his time, such as Einstein, Bohr, and Pauli. He was known for his ability to simplify the most complex ideas while simultaneously posing the most challenging questions. After his death, many of his colleagues, especially Einstein, felt a profound sense of loss. Einstein considered him a voice of reason in a rapidly changing world, a world where modern physics had become bolder and more complex than many could keep up with. Today, as physics evolves faster than ever before, Paul Ernst's legacy reminds us of something fundamental, that true understanding is more important than equations, that humanity is an integral part of science, and that behind every grand theory stands a scientist searching for meaning. Paul Ernst's story is not just the biography of a gifted scientist. It is a reminder of the price of genius, the occasional isolation of scientists, and the pressures that can accompany the pursuit of truth. Don't forget to subscribe. See you next time.